Good morning, sir. This is Leela Vaishnav. I am from ECD section. Today, my tech talk topic on the subject DSP. On the subject, I have to choose the topic windowing. After the signal was digitalized using analog and digital converters, the next step on this process before it can be subjected to FFT algorithm is called window. Windowing is the equivalent of multiplying of the signal sample by the window functions of the same length. The window must be applied to the data to minimize the signals and leakage and effects. This is the principle of the window. The signal was flowing through the through and flow manner. It can be introduced to cuts. The leakage is a discontinuous signal that can be caused a notice FFT diagram. The FFT diagram algorithm reads discontinuous signals sidebanded, so analyzed it will more difficult to understand the diagram. So this is the way how the signal was processing. It was like conclusions to bounded. The next one, the types of windowing functions. There are many windowing types of functions. Those are rectangular, flat top, Hamming, Kaiser Bessel, Blackman and Bartlett. These are the 7 types of windowing functions. The first one is rectangular. The rectangular window as the Bocker is Dirichlet window is the simplest window equivalent to replace the all n values of the data sequence by the 0, making of appear as true as waveform suddenly as turned into on. This is the waveform of the rectangular function. This is omega n equals to 1. Next one is flat top flip-flop. The flat top window is a particularly negative valued window that can be minimized the scrolling loose in the frequency domain, such as window having been made available in spectrum and analyzer for the amplitude of frequency resultant can be high noise bandwidth. These are the waveforms of the flat topped function. The next one is Hamming window. Hamming window is named after the Julius Van Hahn, is sometimes referred as Hanning, presumably due to list of linguistic and formulatic simulators of Hamming window. It is also known as raised cosine. Because of the zero phase version is the one lobe of an evaluated cosine function on the internal Hamming window function is Wn equals to 0.5 at the rate 1 minus cos 2 pi n by n minus 1 at the rate equals to sin square pi by n minus 1. These are the formula of windowing Hamming function. These are the waveforms of Hamming functions. The next function is Hamming. The window which this practical coefficient was proposed by the Richard Omega Hamming. The window is open to minimize the maximum nearest side lobe is giving highest about 1/5 of that Hamming window. It is Wn equal to alpha minus beta cos 2 pi n by n minus 1. These are the waveforms of the Hamming window. The next window is Kaiser-Bessel window. The Kaiser-Bessel window is simply approximation of the DPSS window using Bessel function discovered by the James Kaiser. The Un equals to Ls into Xa at the root of 1 minus 2 pi by n minus 1 whole square by Lp Xa. These are the whole Kaiser-Bessel formula.